Okay, so for the second part of our data that we need to look at in order to plot graphs, we're going to be doing an enzymes lab, and we're going to be needing to plot a whole bunch of different graphs in for our enzyme activity. And so we're going to look at how to plot, for example, peroxidase activity at 5 different temperatures, and then how to determine the optimum temperature for our enzyme. I'm going to go to our video one, which does not have the graph, so that I can show you how to do this. So what I want you to look at right now, okay, is I have this data up at the top that has time and then the 5 different temperatures that I want to plot. I'm going to make sure to grab the data without the title for this particular set because there's an awful lot of data there. You don't want the title as well. It actually confuses it. So go under Insert and then hit Chart. And you can see how it's going to give you weird looking charts, and that is definitely not the chart you want. So you're going to scroll down and find Scatter. You're also going to look at this and realize that it says time in seconds at the bottom, but yet it's got temperature on the x-axis, which is not what you want. So we're going to take off switch rows and columns. Okay? And the reason we did that is because we want our temperatures to actually be the legend on the right, and we want our time to be the x-axis. Okay, after we get done getting it so that it actually looks something like it should, we're going to go under Customization, and we're going to set up our title, which is Peroxidase Activity. Okay, peroxidase activity at 5 different temperatures. And we're going to scroll down. And we're going to realize that we do not have a y-axis label right now, so we're going to go ahead and set that up. And I'll show you in a minute, or after I get done setting up this graph, that if you do forget to do this, you can actually go back and fix it later. Scrolling down, I also want to get rid of the fact that there's a 160 time, so I'm going to put my max as 120. Oops. Oh, not under absorbance though. So I got to go back under horizontal, and I've got to put my max as 120 here. Okay, such that I don't see that 160 because I don't need that. And then I'm going to keep scrolling down, and I'm going to get to the series, and you will notice that there are 5 things under that series. The first thing under that series is 4 degrees, and I'm going to leave that as blue circle, and I'm going to select a trend line as linear. I'm also going to add the equation. And I'm going to do this a bunch of times. I'm going to go back to the series again, and I'm going to go to 23, and this time I'm going to select triangles. And again, I'm going to scroll down, give myself a trend line, and give myself an equation. Third time, come in, do 32, give yourself a square, scroll down, give yourself a trend line, and make an equation. Oops. And I'm going to scroll back up. And I'm going to go under 48, and I'm going to scroll down until I hit diamond, and I'm going to go to a trend line, linear, and equation. Again, I'm going to go to 70. I'm going to now select the star, and I'm going to go under trend line and equation. Once I have my graph with my 5 different equations on the right, my time in seconds on the x-axis and my absorbance on the y-axis, I'm going to go ahead and hit Insert. Okay, I can now drag this over here. Okay, so if you look at your chart, you can also, as I pointed out before, move and resize, so you can drag it over such that you can see the equations a little better. Okay. You probably cannot see the equations as well as you might like, so make sure to make it big enough so that you can still see it, okay? Again, you need to be able to see the entire equation in order to use the data that we need for below. So the second set of data that I've copied in here is actually what you do after you get this graph. You need to take the slopes for every single one of these equations and put them here. So what you're doing is at 4 degrees, that's your first equation, you have a slope of 1.186 times 10 to the minus 3. In order to make that into a number that you want, okay, so going back, I also want a second set of data, and I'm going to grab this data, and we can actually get this from our graph. So what I'm going to do is I'm going to copy it in right now, and then I'll use it later. Okay, so I'm going to copy it in, and I'm going to put it over here. Okay, so our new data, what this data came from, and I'm going to show you that right now, is the slopes from this particular 5-temperature graph that we made. So we had different slopes. The slopes are your m and your mx plus b. So that 1.186 times 10 to the minus 3 is actually the slope that I want to use here. All I have done is I've rounded it up a little bit. So instead of 0.1186, I've rounded it as 0.0012, so I rounded up a little, okay? And then my other numbers are 0.01, 0.012, 0.017, and then my 70-degree one is really, really small, 1 times 10 to the minus 4. So I need to add 3 zeros in front of a 1 here. So now that I have this data, I'm going to go ahead and grab this, and I make a totally different kind of chart. So if you go under Chart, okay, you can see how it's got the data points kind of there, but this isn't really what we want our chart to look like. So we're going to go under Chart Type, and we're going to select this goofy looking thing, and it has not done it correctly yet. I want to use column B as header, as labels. Once you have both of these selected, use the row that you should have started at and use column B as labels. You now have what looks like a smoothed curve, which is what we want it to look like. Okay? We still are not done though, because we're going to go back to customization and we're going to do a few things. The first thing we're going to do is we're going to call this optimum temperature for peroxidase. Okay, so optimum temperature for peroxidase, and we're going to scroll down. We're going to leave the smooth here, okay? We're going to see that our horizontal axis and our vertical axis are correct, but one of the things that we do want to have is we do want to actually see the points, okay? So right now, I'm going to go ahead and select circles so that I can actually see the data points that it plotted. But what I want to point out here is that the maximum on this curve is not this data point. It's a little bit before that, okay? Not a lot before that, but a little bit. And I also do not like what it did for the numbers. So I'm going to change it to auto so that I can actually see more temperatures. Okay? And I'm going to scroll all the way down. And you can see that you don't have to add a trend line because this is not a trend line. This is not a best fit line. You want it to look like this because what you're trying to determine is your T optimum, basically the point at which this thing maximizes out, which on our graph looks more like 46 degrees than 50 or anything else. Okay? And then you're going to hit Insert. Okay? You can get rid of this because you don't need it. So just clear the legend. All right, and then you have this very nice looking optimum temperature for peroxidase graph. Okay, and you can copy this in, like you copy every graph in, into your file that you're going to create in Google Docs. And I talked to you about how to create a Google Doc file last time. So if you click on Copy Chart, I'm going to go ahead and put it in with my other one that I had created in the previous video. And we're just going to scroll down. And you know that you can just either hit Control V or you can hit on the mouse and hit Paste, and it will copy that link in. You can do this for every single chart that you copy in. Okay? Going back. And now that you've done that, you can then annotate and describe what is the maximum temperature and all of that stuff that I'm asking you to do next. You're going to do the exact same thing that I just showed you here for temperature for pH as well. The last thing I want to show you is you're going to do an inhibitor, and it's called hydroxylamine, is an inhibitor for your enzyme. And you're going to end up with a graph that looks like this. So I can take this data that I have in this graph right here, and I can go ahead and insert a chart, just like I've been doing. Okay, and you can see how it always gives you the wrong thing. So you're going to scroll down because you want a scatter plot, and you're going to get 2 lines, and that's exactly what you want it to look like for now. Then you're going to go under customization, and you're going to do some things just like before. So the effect of hydroxylamine, which is your inhibitor, on peroxidase extract. Okay, and then you're going to scroll down, and you notice that you have a horizontal axis that is time, but you do not have a vertical axis. Okay, the other thing that you want to get rid of is, again, I'm going to max out the temperature at 120 because it always puts the extra one there. I am also going to come up and I am going to go under vertical axis and hit absorbance. Okay. And then the last thing I'm going to do is I'm going to add my trend lines, just like I've been doing. I'm going to add my trend line for my normal extract, and I'm going to insert my equation. And then I'm going to add my trend line for my hydroxylamine, and I'm going to insert my equation. Okay, so you should see 2 equations there. You will need them. And then you're going to go ahead and hit insert, and now you've got your inhibitor graph. Okay, that gives you an idea on how to plot every single graph. From here, you are going to calculate the concentration of inhibitor, and I'll show you how to do this in class. That's it for now.